Today we are going to talk about pre-stressed concrete poles. So during last 2 decades, pre-stressed concrete poles have been gradually replacing the traditional poles, that is made out of generally reinforcement concrete. And now these pre-stressed concrete poles are mass produced, widely used in most countries for railway power, signal lines, lighting poles, antenna masts, telephone transmission, low high voltage electric power, substation powers. So you can ask, what is the advantage? Why suddenly a reinforcement concrete, the poles made out of reinforcement concretes are replaced by pre-stressed concrete poles? So there are some reasons behind it, like compared to reinforcement concrete poles, the pre-stressed concrete poles are of reduced cross section, so that's why its weights become lighter, and it is easily handling due to this less weight than other poles. Also, it is freeze thaw resistance in cold regions, resistance to corrosion in humid temperature climates, and clean, neat in appearance, and requiring negligible maintenance for a number of years, thus ideally suited for especially the urban areas. And it has a increased crack resistance, and also it has rigidity and also can resist dynamic loads, actually better than reinforcement concrete poles. So these advantages generally have resulted in the rapid development and use of different types of pre-stressed poles in various countries. It may be UK to US, Germany, Norway, India, and others. In India, the use of pre-stressed concrete poles has so far have been confined to generally lighting columns and for transmission of power for, let's say, up to 11 kilovolts. And in view of rural electrification in India, it is estimated that there will be a demand of 2 million poles annually. So obviously, which will further increase even the electrification of new railway lines. There's a very good portion, a chunk of concrete poles or the poles will be needed. The pre-stressed concrete poles, because of different advantages, it is better suited. So it is important to know how to design pre-stressed concrete poles and what are the shapes and general criteria is about how to design pre-stressed concrete poles. So before that, you have to know that pre-stressed concrete poles come in different shapes because of different benefits of different shapes. So maximum moment of resistance in a pole is generally required at the base. So obviously the maximum cross-sectional area, the section modulus will be needed, also will be required at the base. So that's why the cross-sectional area also will be high at the base section. So generally that's why poles are generally tapered with a hollow core so that it can reduce their weight, and also it helps in providing a race away for electric wires. So typical cross section of transmission line poles are different in different countries. So for small lengths of up to 12 meters, the square rectangular section are preferable as they are easily manufactured and occupy less space in transportation. Still there are different shapes like tubular, polygonal, electrical, hollow square, B-type, I-section. Different type of cross section are used in different countries. So now to design a pre-stressed concrete pole are for some following critical load condition. First is the bending due to wing load on the cable and on the exposed face. So main load is wing load because of its heights and because of generally keeping a wide open areas. So bending due to wing load is on the cable as well as the exposed face of the pole is very important. Then combined bending and torsion due to eccentric snapping of wires. Okay, so the snapping of wires and this eccentricity of the wires as it is developed, so it will automatically will develop bending as well as torsion at the section of the pole. So also bending due to failure of all wires on one side of the pole, suddenly it may happen, so that also you have to consider. Also the handling and erection stresses are there. Also due to snapping of wires in skewed fashion, and which will produce maximum torsion in the pole. So one is you have to consider the bending due to wind load. Also you have to consider bending torsion for eccentric snapping of wires, maximum torsion because of skewed snapping of wires, bending due to failure of all wires on one side of the pole, and handling and erection stresses. So load factors generally required for strength and serviceability checks. So Indian Standard Code IS 1678 provides that for a load factor of 2.5 for transverse bending strength. Okay. So and another thing is that the flexural strength of the pole in the direction of cable line should not be less than 1/4 of the strength in the transverse direction. So one is load factor of 2.5 of transverse bending strength has to be achieved, and another part is the flexural strength of the pole in the direction of the cable. Direction of the wires should not be less than 1/4 of the strength in the transverse direction. So these two conditions you have to must be fulfilled as per IS code 1678. Also smaller load factors ranging from 1.1 to 1.5 are prescribed for failure due to combined bending and torsion as a result of snapping of wires. So in the case of tapered poles with a reduced cross section towards the top, as you are going from base to top, so base it will be maximum area and at the top it will be the minimum area, so this tapered section, so effective pre-stressing force should be reduced in proportion to the cross section. How we will achieve that? You have to use the technique of debonding. So as you go up and up, your requirement of pre-stressing steel of wires will be less. So you have to debond as you go along the length of the pole. Though a constant cross section proves to be better solution in many cases, since the top section must be as strong as the base for resisting torsion, and also with the added advantage of the effective use of pre-stressing and easier connection. So a constant cross section proves to be a better solution in many cases. Okay. But tapered poles, if you are using, you have to the pre-stressing force should be reduced as you are section also getting reduced from base to top. So as if you designing a pre-stressed concrete pole, first you have to design the section, right, based on the wind loads, how much winds are coming, and based on that you can calculate the design section. So you assume some width and how much wind force are coming, so from that you can calculate the section modulus, and from that you can get a depth. So you will getting the width as well as the depth of the section, how much you can provide, right? As you are getting this, so you can then go for how much wires is needed or how much pre-stressing steel is needed. Okay, so for that you have to go for how much pre-stress is coming in that particular section. So if you know the how much the maximum stresses which you can allow in the section, like in the concrete, how much stress it can bear, how much tensile stress it can bear, how much compressive stress it can bear. So it is mainly the tensile stress, how much it can bear. So this, if you take the tensile stress, you want to keep in the section as 0, meaning that you are not allowing at all any tensile stress in the section. Then you can say it is a fully pre-stressed section. So, and it is known as type 1 structure. And if you allow pre-stress and the tensile stress somewhat more, depending upon the modulus of rupture of the concrete. So if you're limiting that, you are keeping the tensile stress, but you are not much you are allowing. So let's say some value is given for modulus of rupture for the concrete and you are allowing less than that. So obviously crack will happen within the structure, but it will be micro cracks. So this type of structure is known as type 2 structure. And let's say you are allowing your tensile stress to be more than that, so there will be obviously more structural cracks within the section, so that, and it will be visible cracks, especially from outside also you can see. These are the type 3 structure, and depending upon how much exposure, how much environment, and where you are building the structure, depending upon that you have to decide. Because only pre-stressing steel if you use, it will be costly. So if you can allow some kind of cracks, and so that you can reduce the pre-stressing steel, the amount of pre-stressing steel, and so that will be cost effective in that sense. Now, so as you are calculating pre-stress, and then from that how you can calculate how much wires or pre-stressing wires is required. Then as you get the section and how much steel pre-stressing wires are required, from that you can check for limit state of collapse, and so you can calculate the moment of resistance of the section, and actually how much working moment is coming, and actually how much moment resistance is actually your section which you are allowing. So it has to be less than your moment of resistance should be greater than the working moment. That's the idea. So then you check for limit state of cracking, how much cracking width is. So as per IS code, it should not be more than 0.1 millimeter. It should be less than that. Then you check for limit state of deflection, how much deflection you are getting. Then check for the torsion due to skew snapping of wires, and if shear stress is coming more than which is allowed, then you have to go for stirrups or transverse or reinforcements, and longitudinal links you have to use. And then you just check as your section, your design the section, let's say it is tapered, so from base to top your section is getting reduced. So how you are going to effectively use the pre-stress, so that also you can design, means how you are going to debond as you are going from base to top, that also you can design. So that's how we can design a pre-stress concrete poles. And if you check it with reinforced RCC concrete pole, you will see that this section is much less and it will be lighter also in weight. You can compare that. So I hope you get an idea of what are the advantages of concrete poles over RCC poles, and how you can design a concrete pole. Obviously it's a design problem, so you have to go to book and you study the book, but you get an idea hopefully. Thank you.